I'm Allan Deutsch, and this is my talk on the preprocessor. So hopefully you'll learn a few things that you may or may not benefit from, because it's the preprocessor. But yeah, you'll probably learn some things. So a quick overview is that I'll be going over common problems with the preprocessor, some of the basics, how macro expansion works, some utilities, and then some useful things with the preprocessor and places you can look if you're looking to do like more really advanced stuff with the preprocessor. Fun fact also, while the preprocessor itself isn't Turing complete, it can be used as the machinery in a complete Turing machine because someone wrote a brainfuck interpreter using the preprocessor, and brainfuck is Turing complete. So there's your fun fact for the day. Also, this talk is like super cursed. I was trying to give it over summer, and then like the first time I was sick, and then the second time I had to reschedule it because like something came up, and then the third time, like after all of these reschedules, only one person was able to make it. And so then finally people were requesting it for this semester, and then I was sick again the first time. So this is like the fifth time I'm trying to give this talk. And then more things happened today, but I'm here anyway because I didn't want to keep letting it drag on. So yeah, fun fact about this talk. So common problems with macros. They can be really hard to debug. Macro expansion happens in a single pass. So kind of like how headers get parsed in a single pass, and so you can't have like a usage of a class without forward declaring it. The same is kind of true with how macros are expanded. So that'll be covered a bit more in how expansion works, but that's one of the issues that people can encounter. There's no preprocessor directives allowed inside of macros. So if you're like defining a macro, it can't also have its expansion include preprocessor directives such as like pound if conditionals or something. Those just aren't legal because of this fact that it's single pass. So it would just end up as an invalid token that gets pasted there, and then your compiler yells at you. So it's also like the dumbest thing ever. Like all it does is copy and paste. Like that is the entirety of what the preprocessor does. It's a complex series of copy and paste operations. So it can be really useful, but it can also be really inconvenient. So the basics that you can do with the preprocessor, as I'm sure all of you know, you can include headers. You can define values. So for example, you can define pi as a number that people recognize and get an actual number out of it. You can define other types of constants, such as C-style strings. So like here, hello world would expand to the null-terminated string hello world. You can define keywords. And a neat thing about this is you can have conditionals around this. So for example, noExcept is supported in Visual Studio 2015, but not 2013. So you can have a preprocessor conditional to check the version of the Microsoft compiler. And then depending on whether or not the feature is supported, you can have your own macro defining this keyword so that it will either expand into the keyword itself or nothing. That way you can use noExcept or whatever other feature, such as constexpr, in places where it's supported and just have it be stripped out by the preprocessor where it's not. So this can be a really neat trick for when you're trying to migrate your code base into a more modern compiler, but you're not able to use that modern compiler on all of your platforms yet. You can also define things like a macro function. So here we have a print macro that just passes all of the arguments into a call to printf. You can also use it to do more complex things. So here, for example, you pass this make component macro a name parameter, and then it builds the head boilerplate for a component class with the pass name, and it'll inherit from your base component class. And you can do a lot more advanced things with it, but that's kind of the basics. So in macros, you have 4 operators that you can work with. You can define something. So those are all of the macros that you have. They can be the literals, the functions, any of those things. You can stringize. So that's the single pound sign. And what that does is literally takes whatever is after it and wraps it in double quotes. And then you have the token pasting operator, which takes the thing to the left of it and the thing to the right of it and just puts them together, like straight up copy paste. So if you have like, some enum prerequisite, like, comp and then like underscore and then all of your component names, and you use that, you can paste them together inside of an enum to make all of those enums prefixed with that like CMP underscore. And then finally, you have continued on next line, which isn't really an operator, but it helps make your macros not ugly because you can split them onto multiple lines. Because normally, by default, the preprocessor only allows you to write things on one line. And so using the slashes allows you to have it a bit better formatted so that when you have to go back and edit your macro because you did it wrong, it's more readable. So other macro tools that you can work with are all of the preprocessor conditionals. And so those are really beneficial because, as I explained earlier, you can change how keywords are expanded and other things like that in a way that makes it a lot easier to have control flow before the actual program runs. You've also probably used them for your include guards, like the if and def include guard. And then Pragma also exists and can do things sometimes, but that's always compiler implementation dependent. It's like none of the Pragma directives are actually part of the standard. So be careful using them. The only one that's pretty much safe everywhere is Pragma once, and I encourage you to use that everywhere instead of the if and def include guards because it's objectively better in terms of like performance and safety and reliability. And it's supported by literally every compiler you care about, like GCC, Clang, Borland, Microsoft compiler, Intel. I'm pretty sure IBM's compiler supports it as well. Like literally every compiler you're going to be touching will support it. And if it doesn't, you're probably not using that compiler. So that's the one that's safe to use, and like I highly encourage you do. So the steps of macro expansion. There are 4 steps of it. So the first one is it processes tokens that have the actual operators, so the string eyes and the concatenation operator. Then it will apply macro replacement to any of the arguments being passed to your macro functions. And then it replaces the parameters with the result of that macro expansion and scans for more macros. So these are like the steps that it happens in. And so there are some tricks to this that you need to be aware of that I'll be covering in a little bit. So here are some simple examples, right? You define pi as 3.1415f, a very common float constant for pi. So then when you expand it to like 1 times pi, it expands as 1 times 3.1415f, right? Very typical, exactly what you'd expect. Pretty much the same thing with other constants such as stir, where you have hello world. You see out your stir literal, and then it actually expands into see out hello world. Then you can get into some slightly more complicated things, such as this multiply one, where you're multiplying x and y together. And obviously, you'd never do this because you have operator multiply, but this is just a good example. So here, we're passing in an expression as opposed to just a single thing, and then the 6. So what happens is it expands to exactly what you told it to, which is x times y. X is 5 plus 5, and y is 6. Then operator precedence kicks in when the compiler runs, and you get 5 times 6 plus 5, which is not what you wanted. So you have to be careful with things like that. So one simple approach for this is to wrap each parameter in parentheses, right? So if you have your x wrapped in parentheses and your y wrapped in parentheses, then it does 5 plus 5 as a grouped expression, which will then have precedence over the multiply operator. You multiply that times 6, and you get 60. There's the expected value. But you can still run into issues. Say, for example, you wanted to do 100 divided by your multiplication. Then your operator precedence for that previous one would have been 100 divided by your 5 plus 5, and then multiplied by 6, which would give you the wrong value. So you have to, again, wrap things in more parentheses, this time wrapping the entire expansion in parentheses in addition to each of the subcomponents. And then you can get 100 divided by the result of your 5 times 6, which will give you your roughly 3 1/3. So that's the value you would expect. Another useful thing you can do is define types. So for example, my vec type or my stir or whatever. And then you can just use it as normal, so like as if that were std vector, and then templatized for int or whatever, and it'll expand correctly. And the benefit of this is that if down the road you decide you want to implement your own string class or your own vector or whatever, and you don't want to have to go through like the code base with Control F and like find and replace all of your instances of it, you can just change the one definition of what that macro expands to be whatever your new implementation is, and then everywhere in your code base it'll use your new version. The better way to do this is using the C++ 11 using which is similar to typedef. You couldn't do it before because you couldn't typedef for an entire template, so that's why this is here. But after C++11, you can do a templated using statement. So you would do like using my vector or whatever equals std vector, and then that works. But before that, this is the better approach to take. So another example is if you want to say screw you to const correctness, you can just define const as nothing. And then it gets rid of all of your const. So A+ stuff there. But it can actually be useful, like in the example I mentioned with no accept or const expr, where a compiler doesn't actually support a keyword in certain versions. You can compile those out depending on certain preprocessor things that are available to you. So some slightly more complex expansion, right? We have this define stringify x, and then we pound x, and it should wrap it in quotes, right? So then we define pi as 3.14, and then we want to stringify pi. So these are the expansion steps. Who can tell me what stringify pi will do? Any ideas? Very good. Right. So do you know what it'll do? Yep, it'll be pi in quotes. That's correct. And that's probably not what you're hoping for when you tell it to stringify pi. So it'll expand into this with the first step. Then it wraps it in quotes. And that's a problem, because you didn't actually want to print the word pi. You wanted the number. So we need to add a couple things to our macro here. We have a stir inner, which is essentially just an indirection for the preprocessor to make it do another pass. And then in that stir inner, we then do our pound x. So what happens here is stringify pi will go from stringify pi. It finds tokens with pound and double pound, which there currently aren't any. It replaces the macro arguments. So since the macro argument was pi, that's now expanded into the number you defined it as. Then it expands the macro. Then it rescans for more macros. And then it can do the expansion of the macro and process the token with the pound before it. And now you actually get the result you wanted. So that's why it can kind of be inconvenient that it does things in the single pass, because sometimes you have to force a second pass in order to get the result you were expecting. So some simple macro utilities that you might want to use are these. So you have concat, which just takes x and y and puts them together. So in that first example, assuming it were actually passed like the literal character x and y without quotes or anything around them, it would expand into capital X, capital Y, like without quotes or anything. So that can be really useful. Stir inner and stringify, as you just saw, are how you can take whatever expression and wrap it in quotes. So stircat is a way to concatenate and then stringify the result of your expression. And then enumify allows you to take a prefix and then whatever the value is to prefix all your enums with something. And then you have a comma at the end so that you can just make all of your entries into an enum using this. So some useful things are that debugging macros is a lot easier than you think once you actually understand at a deeper level how the preprocessor works and like the steps that it goes through. And writing repetitive code can be really avoidable using the preprocessor. So if you're interested in some really advanced preprocessor things, you can check out Boost Preprocessor and this other thing that some guy on GitHub has. It has a lot of cool tricks and like more advanced things that are probably less practical, but still could be useful and are really helpful to know. So in CS380, which is taught by Steve Rabin, there's another trick that you'll learn about the preprocessor. So we have this messages.h file here. And then in that file, you have a macro and then an argument to it. So the macro function in this case is message, right? So all of the messages that you can send in his state machine language are defined in this file. So anytime you want to add one, all you have to do is add one line to this simple file, right? It's very straightforward and easy to do. And then something similar to this left side is what's going to be happening behind the scenes. So first it'll define message x to expand into the enum version. And then inside of the enum, he actually includes that header file. And so what happens is all of these macros will get expanded inline into that enum. And so all of those entries will then be like MSG underscore restart, MSG underscore attack, et cetera. Right? So then you get all of those. But then it doesn't stop there. You can also then undefine the macro, define it as something new, this time stringifying it, and then include it into an array of const char pointers. And then that will take them all and turn them into strings. So then you also have the string and the enum version. And coincidentally, since enums automatically start at 0 and then go upwards, you can put max at the end, and that allows you to iterate over them for like I equals 0 to I is less than MSG max. And then you can index into this array of characters with it, and that allows you to get the string value that corresponds to each enum. So if you've ever tried to print an enum value, you get a number, and that's not very helpful. But getting the actual string value is much more valuable. So I have a little scripting demo thing that I've put together, which shows some practical uses for some of these macro tricks. So I'll go ahead and bring that up now. So this is like a very, very basic example of a scripting language that you can implement. So you'll see here I have some enum struct that I defined. Oh, I see. It's just too small. All right. Yeah. So here's like a really basic enum struct you can do that allows you to map strings to integer values so that you can more easily go between the two in your code. And then I have something similar. So here you see there's these instructions. Oh, sorry. It should automatically keep them the same size, but it doesn't. I don't know why. Is this big enough? OK, cool. Yeah, so as you saw before, all of these instructions are macros, and then you have something inside of them. And Visual Studio already knows that these are going to be expanded as enums. So you can see that they're highlighted as enum entries. So then we have this instructions enum file where that expansion happens. So we define what the macro should be. We then include it inline in the enum, and it will be expanded. And then I also have an invalid value. And then we can generate the same things for the strings as well. So that's here. So that's kind of interesting. It gives you a way to more easily work with things that you want both as an enum and a string. So an example of this is that all of those get automatically parsed by this project and pushed out into a text file. So I'll open that up real quick. So you can see here, they're all there. And then if I were to add something to it, like I can go down here and say instruction, and then laugh, right? That seems like a valid instruction for a scripting language. And then we build it and run. Since it can convert those enums into a string, it's able to generate a text file which will have the new value in it. I believe it's this one. Nope, maybe not. It's somewhere. I don't know. It's hiding from me. Oh, it was in there? Here? Yeah, it says script. I'm sorry, it's really small. But anyway, it can do that. Just trust me, it does work. I didn't write that text file. But yeah, so then you can do more interesting things with it. Like to parse it, I have this file. And then all of the different instructions are interpreted by a simple switch statement, right? So you have like add, and it'll do a thing. and subtract, and it does a thing. And so this language is really simple. It works off of a stack, right? So the point is you can easily add instructions and do things with them. But it also means that parsing is like the easiest thing ever, right? So we go here, we get the instruction, we get the enum value from the instruction string, and then we can simply call it with this number, and it'll go into the switch case and use it. So an example of that is in here. So this allows you to enter an instruction in the language or run a script. So I'll show you this script here, right? We have some really basic logic. We push a variable onto the stack. We get a value based on that variable. So what happens here is it's basically pushing the ID of an entity and then getting a value from that entity. And then we're going to get the level. So then at this point, it's popped 0 off the stack and replaced it with wisdom. Then you push 0, you pop the 0 and get the level. And then you can multiply it, right? So that's like multiplying your level and your wisdom. And then you can get your HP, add them together, and then set your HP as it, and then print it. So the way that works is we're going to run a script, and then we can do heal.script, and then it's able to print out our health times our wisdom, right? So then if we run it again, it keeps healing us. So all that spell does is run, where'd it go? It runs this, and all of that is done using the preprocessor to just expand macros. And then that's how all of the parsing does, all of the serialization, and then all of the interpreting basically is just done by using preprocessor expansion. So that's an example of like how you can practically use these things in a game. Like if you wanted to implement a console with custom commands like spawn an enemy, and you wanted it to be really, really easy to do, you can do this. And then your designer goes in and they write one line in a header, and then they write the logic for it, and then they can open your in-game console and type in spawn enemy, and then you get an enemy. Question? I don't know how they're implemented, but this is like you wouldn't want to implement a scripting language this way because like as you saw, that code is like horrible. No designer would want to write in that. But if you want to implement like an in-game console for debugging purposes, or like if you want to spawn an enemy just to like test out values or whatever, then it's a really easy way to do that without having to have a full-blown editor running in your game. You can just have an out-of-game editor and an in-game console that you can use to run these basic commands. And then it's a lot faster and easier to debug with it. So that's like one practical example. And there's, of course, plenty of other things. Like just that multiply including a file to expand into an enum and string can be really valuable on its own. So any questions? No? All right, cool. Oh, question? So what do you mean by going from a string to an enum? Oh, so creating both the string and the enum from a macro parameter? Yeah, okay. So that's here. Right, so what you do is you have these like macros that you're wrapping around some value. Right? So restart is the enum and the string that you want, and attack and collision and all of these other things. Right? So those are the things that you want in both your enum and in your string. So then over here, you first define message to expand into message concatenated with x, where x is the parameter to your macro. Then you include the file that has these things listed, so you can see it's messages.h, and that's where these things live. And then you include messages.h inside your enum definition. Because, like I said, the preprocessor just does copy and paste. So literally what include does is it takes this file and copy pastes it into your enum. Yeah, then it expands them. And then you can redefine message to do something else and include the file again, and it'll be expanded a different way.
So it's a parallel safe definition of enum and strings that updates like in parallel.
Yeah, so like when you add one here, it automatically adds it to the enum and string. So it reduces the number of steps to do something like that. And so a lot of people will have like an enum corresponding to their components, and you can have that happen automatically and have the string version and maybe define all the boilerplate for your component class as well. So it can be a really powerful trick. And then in order to go from the string to the enum, that's where that custom enum class that I showed you comes in. By sticking all of these things into some sort of associative container, I use a map. You can then take either of the values and get the other one out.
So like a dictionary.
Yeah, exactly.
Don't put pragma once in methods that
Yeah, don't do that.
first time I tried doing it, it just didn't work. I was like, I don't understand this. You can't put plus.
Yeah, so there's a few problems with that. Even if it did work, you would get pound pragma once in the middle of your enum, which would be a compilation error. The other issue is that since the enum and the strings are defined in the same compilation unit here, the pragma once would say, oh, it's already been included in this file. I'm going to just ignore it for the next one. And so then you would get it in your enum and not in your string. And that goes the same for the if and def include guards. But if you want to be safe, you can use them and then manually undefine whatever the macro that you're using as your include guard is. So for this, it would be like messages underscore h, for example. You could manually undefine that before including it again, and that's a way to work around it. But really, like if this file is meant to just be included a bunch of times all over the place, then you might as well just not bother, because that's the intended use for it. So having an include guard doesn't really make sense. Yeah, also IntelliSense will not be happy with this, but as long as you're not doing anything too complicated with it, it's usually not a big deal. I did things too complicated with it. That's how like all of our serialization gets generated and all of our script binding and everything. It's all done using this. So don't do that. Do the thing that Cody's going to be telling you about in like a half hour for using Clang to automatically generate all of it, because that's a much cleaner and more scalable solution. So any other questions? No? Cool. That's the end of my talk. Thanks for coming.
One thing, when you were showing your cat,
Yeah?
cat